Today we are in Detroit, Michigan, trying to destroy our braking system. I came out to Detroit a little bit early to meet with some suppliers. This morning, I was meeting with Cummins and Meritor, talk about the parts we're using, axle sourcing, steer axle, rear axle, drive axles, drive lines, all of those things that we use into the truck, because as we're getting this new shop ready, concrete's starting to look, I want to make sure that supply chain's locked in. We have that design freeze and everything is good to go. So basically, I'm out here, did a few early morning meetings. I can tell you they went really, really good. I wish I could film more, but that is their testing facility and we can't film their stuff, obviously, while we're in there. But rest assured, sales guys we met with are fantastic, really been supporting us a lot. It was a good meeting. Now I'm looking forward to the next few, and hopefully later we will connect with Theron and Jen. Jen here is responsible for setting all this up. She's here today to observe the test. So what are we going to be doing?
So we will be doing some brake burnishing, which takes about 16 hours, and also some brake testing for CMVSS 121.
This is what Link specializes in. They are automotive testing centers. If we want our government compliance on our new electric axles, we got to bring it here. They're going to put it through all the paces and then see how this does. I am very, very nervous. We put a lot of time and effort into these axles. This is now the big point is, will our braking system pass the test or not? This is the dyno assembly right here. This is the electric axle and the wheel end. This is the assembly they made. Basically, this big flywheel here is going to spin. It just finished its brake burnishing. Just took the pads out. We're going to have a look here. So this is what the brand new pad looks like. You'll see they got these strips on there. The whole point of that burnishing is take all these initial strips off. They did notice the pressure was high on the first few applications. That's just until they got these worn off. And then they run it for 16 hours, constantly braking until they shave this down. And then you got what you would represent average braking with worn brake pads. And then the next important test is what is coming up. They're gonna spin this, and then they're gonna try and stop that giant flywheel. There's a big flywheel behind it. Hopefully we'll show you that in a little minute. And then this thing is, now those brake pads are a little worn, they're gripping. We're gonna do some hard brake applications and make sure that our braking system stops the weight of the truck.
Right here's the inertia discs that simulate the load of the vehicle on the machine to transfer to your brake so it mimics the vehicle. We are running 1,384 slug.
So right here, this is cool. Drilled a little hole, and this is a little sensor to monitor all the information like temperature and that we need. Just wanted to point something out that on these electric axles that it is all ConMet. So ConMet is pretty well the standard wheel end thing. So even though it is a weird electric axle, it's all the still standard parts. Like you got your 2225 brake calipers, ConMet wheel ends. It's all standard stuff.
So we're currently running some testing. We'll be doing some all night, and tomorrow we will be back to see if these axles are road legal or not, and if we have to go back with the team and work on this.
We are in Thomas Edison's original workshop here at Menlo Park, and what you can see up here is how things used to be done in the old factory settings. There's an old steam boiler back there that produced power in a giant belt running up to this shaft that runs the length of the warehouse. And then from that, if you needed tools, you had to run them off of that large belt, which means that you were limited on where you put basically your tools for your workshop. This caused issues for Henry Ford because he wanted the most efficient production line possible, and that wasn't always possible with this old mechanical drive system. So, being a big fan of Thomas Edison, Henry Ford adopted electricity, and he was able to take all of these tools to make his cars, turn them into electric. That means that he could locate the tool exactly where it needed to be, not where the belt pulley system was, to really optimize the entire efficiency of the design of his shop. How I really tie this in is to how it looks when you're comparing it to trucks now. Right now, the conventional diesel truck is limited to its drive shafts to either run a PTO or hydraulic PTO. It means that you can't always mount something where it's more convenient. You have to mount it where the chassis is. Imagine when you're talking about things like cranes, concrete mixers, pumper trucks, hydrovac units, anything like that that needs these extra accessories, you have to remount them now where it's convenient for those output shafts. When you go to electric, there's so much more possibilities to really make things more efficient. And this is like the primary example here, right in Thomas Edison's workshop. Pretty cool. So me and Jen, who I will not refer to as Compliance Barbie, are back at the Link Testing Center. This morning we are going to figure out, did our axles pass? They've been running that test for the last 16 hours. A little nervous. We had a great day yesterday at the Henry Ford Museum. We checked a few things out, but now it's the moment of truth. Do our axles meet the requirements to be on the road?
I'm feeling confident,
That's good.
but we'll see.
I'm feeling
pretty
good
shortly.
too.
Yeah.
You think about it, everything is off the shelf parts, everything is pretty standardized.
Let's go check it out.
Yeah. Unfortunately, I got some bad news. Our first test of the braking system here did not pass. There's a few things we're going to be looking at. Exactly what went wrong, where did it? A lot of the things did pass. That's the good part, is that 95% of this setup passed. We had a couple issues just on the brake pads a little bit, so we're gonna have a look at that, see what we can do, see what we can change, and hopefully we're gonna run another test here. The other one is still on its burnishing, so we do have the second set that's undergoing a set of tests. We'll see how that one does, but I'm gonna stay here, see if I can make a couple little changes and get this thing to pass today.
We ran the test on the electrical axle, and it ran the burnish fine. When we went and ran the performance, it did not meet the criteria. We got a little bit zealous on the load, so we're gonna lower it to a more realistic number, and we're gonna run it again.
While we wait for the other test to happen here, I have to go. I have a flight to catch. So it's gonna be Chace and Jen.
Yeah, we're gonna stay behind here. We're gonna stay a little longer, see what things we need to change, see what we need to do to kind of improve these axles, improve the test, and get the desired results we want. So yeah, we're gonna stay in, put the overtime in, and hopefully get something done. But also, because Theron's going, I am sorry about the video quality that is about to happen in the second half of the video, because we're now relying on my video skills instead of Theron's.
Cell phone. I am leaving the lab, so he shouldn't have an excuse for poor audio.
I know how to work those. All right, so we are now doing the retardation test again. We've already passed the brake burnishing. We've made those changes in the parameters, and I'm feeling really, really confident. So far, about 50% of the way through the test, and it is passing, but I don't want to jinx it yet. One of the big issues that we had and why we were not passing was that there was a little bit of lost communication, a little mistake we made. It was 100% on our team's fault. These guys are running the test, we told them, but we were testing. So the idea was we were supposed to be testing to 23,000 pounds. We were testing because the loaded drive weight on the truck is 24,000 kgs. We were testing that to pounds, but when we did it, we ended up testing the tri-drive axle assembly to 95,000 pounds. That means that you were having 95,000 pounds on the truck and stopping that much weight on the drives. Obviously, in real life scenarios, you're only sitting there around 55,000, 60,000 pounds on a drive axle in your most case, or about 24,000 kgs. Not what we were running, but that's actually kind of nice to know, is that it still braked. Even with 95,000 pounds on the drives, it still braked, it still stopped that truck. It just did not do it in the minimum required distance with the minimum required pressure that it needs to do to be road legal. So we put it down to the road legal test. We're now testing at the 23,000 pounds where it's rated to, so that in a tri-drive configuration, we can be at that 66,000 pound rear end rating, because that would be the same as our Meritor RZ166 in the mechanical truck. The electric axle on the same rating. It's passing that test so far, so that was our big mistake. We've changed it, now we're passing, and I'm feeling a lot better about this going forward. Last one coming up. So far, all of these from test 1 there, being 69, all the way down, 63. What did we have to be below?
85.
Had to be below 85. Last one is coming up. 63, it passed. You can tell I am very, very happy here, but we have now passed the retardation test. That was the last test. We made the changes we need to make. It now meets all the requirements. It did 20 full stops. It stayed below 85 PSI, which means that that is a passing score. We're happy, we did it. It is now, that is a road legal axle. We have proven it. Next step will be to increase some of that weight, find out where the max, but it meets the highway legal limit. Yeah, I'm happy. Good job, Jen. That went so well on the second test. I'm so happy. Jen, you happy?
This trip paid off. We came all the way to Detroit, checked it out, and was a great outcome.
I'm glad we came out ourselves. I'm glad we were able to be there, provide that advice, that guidance. And I gotta give a big, big thanks to Link here, especially Jeff and Mike, who you guys seen in the video. These guys were fantastic, just 10 out of 10. They helped us walk us through the process. They explained everything. They gave us some good feedback, some good advice. We were able to make those changes on the fly, adapt to issues that they came up, and we got so much done because of those two. So Jeff, Mike, if you're watching this video, I really, really want to say thanks for how much you helped us out here. Yeah, well, I guess we head back now.
Off to the next thing.